Welcome to Jom Studyla YouTube channel. Today we will be discussing the topic hydroxy compounds for A-level student, and in this session we will touch several important topics related to hydroxy compounds alcohol, the aliphatic alcohol directly to the alkyl groups, and also we will touch about the aromatic alcohol that related to phenol. Without further ado, let's get started. Hydroxy compound alcohol. Hydroxy compounds are organic compounds containing a hydroxy group dash OH. Types of hydroxy compounds. Aliphatic alcohol is derived from alkanes with one or more hydroxy dash OH groups. The OH group is directly attached to an alkyl group, saturated hydrocarbon change, and general formula is CnH2n+1 OH. So the diagram as shown below. Likewise, aromatic alcohol contain a hydroxyl dash OH group attached to an aromatic ring, aryl group. An example is phenol, where dash OH is directly bonded to a benzene ring. For the hydroxy classification, methyl alcohol, nomenclature as specified below in the table. For the structure CH3-OH, general name is methyl alcohol and the IUPAC name is methanol. And for the structure CH3-CH2-OH is referring to ethyl alcohol and the IUPAC names is ethanol. And then we have CH3-CHOH, and CH3 is referring to isopropyl alcohol, which is IUPAC name is 2-propanol. And this is the diagram, which is the structure linked to OH. And then the general name is cyclohexyl alcohol, which is IUPAC name is cyclohexanol. Naming the alcohol, the name is derived from the corresponding alkane methane by replacing the dash E with dash OL. Methane become methanol and is used for alcohol with a single dash OH group, monohydric alcohol. For the IUPAC rules for naming alcohol, you need to identify the longest carbon chain which containing the dash OH group, and you need to replace the dash E of the alkane with dash OL. Example, ethane, it become ethanol. And then you need to number the chain starting from the end closer to the dash OH group. And then thirdly, you have to indicate the position of the dash OH group with the number if needed. For multiple dash OH group, uses suffixes like dash DIOL, dash 3 TRIOL, and etc. and retain the final dash E of the alkene. Example, CH3-CH2OH is referring to ethanol, and CH3-CHOH CH3 is referring to propan-2-OL. Alcohol with two hydroxy groups, diol, DIOLS, is called diols or glycols, and two dash OH group must be indicated with their respective position. And then use the suffix dash DIOL and keep the dash E in the parent's alkene. Example we have here is HO-CH2-CH2-OH is referring to ethane-1,2-diol, DIOL, which is the common names for ethylene glycol. And then we have the alcohol with two hydroxy group. The structure is CH2-CH2 CH2OH. CH2-OH is referring to ethylene glycol, and the IUPAC name is 1,2-ethene diol. And then we have the rest for 1,2-propanediol, and also we have 1,3-propane diol, and also we have 1,2,3-propan triol. And then physical properties. Most simple alcohols are liquid, where ROH with C is greater than 12 are a solid, meaning that alcohol where the alkyl change R group has more than 12 carbon atoms are typically solid at room temperature. As the number of carbon atoms increases, molecular weight and van der Waals forces is also increases. And these stronger intermolecular forces lead to higher melting and boiling point. Beyond 12 carbons, and this alcohol become waxy solid at room temperature. Example, cetyl alcohol, C16H33OH. And on top of that, there is also additional classification. For example, like primary alcohol. So in a primary alcohol, the carbon atom attached to the dash OH, which is hydroxy group, is the only connected to one other carbon. Example, ethanol. The dash OH is on a carbon that is only connected to one other carbon. And in terms of the structure is R-CH2O. And for the secondary alcohol, the OH, the dash OH group is attached to a carbon connected to two other carbon atoms. Example, isopropanol, CH3, CHO, and HCH3. And this is the structure for isopropanol. And then we have the tertiary alcohol. In a tertiary alcohol, the dash OH is on the carbon attached to three other carbon atom and no hydrogen atom directly on the carbon bearing the OH. Example, we have the butanol, then the structure is shown as below. And for the third butanol, the boiling point of ROH is greater than alkane and RX, alkyl halide, because of H bonding. Alcohol have higher boiling point than alkene, alkyl halides, where R-X, where X is a chlorine, bromine, and etc. Then we have the hydroxy compound for alcohol in terms of the combustion of ethanol, and the formula is CH3CH2OH plus 3O2 to become 2CO2 plus 3H2O. And this is a complete combustion reaction of ethanol, a primary alcohol, where ethanol reacts with oxygen to produce carbon dioxide and water. And this reaction is exothermic, meaning that it releases energy in the form of heat and light. And it is the basis for ethanol being used as a fuel or biofuel. Then we look at the substitutions to form halogen alkenes. And the process is, this is a nucleophilic substitution reaction where the dash OH group in the alcohol is replaced by the halogen atom to form halogen alkane. And this reaction typically require heat and often a strong acid catalyst as a sulfuric acid to generate the hydrogen halide in stew within the reaction mixture. For example, HBr can be made by the reading NABr with H2SO4, and the reaction with sodium, where alcohol react with sodium metal in a similar way to water but more slowly. The sodium donates electron to form oxide ion, and hydrogen gas is released as bubble. And this shows the weakly acidic nature of alcohol, where they can donate a proton from the dash OH group. And this product is a sodium alkoxide in the case of sodium hexoxide. Let's look into the hydroxy compound alcohol in terms of the physical properties. Alcohols and water have the ability to form intermolecular H bonding. H bonding happens as below, where alcohol have N-OX, hydroxylic group, and the oxygen atom is electronegative, pulling electron density away from the hydrogen. This make the O-H bond polar. And this polarity allows alcohol molecule to form hydrogen bond between themselves, like alcohol linked to alcohol, H bonding, and with water molecule, alcohol with water H bonding. And methanol, ethanol, and propanol are completely soluble in water, and their short hydrocarbon change are small enough to the hydrogen bonding dominates and allow them to mix well with water. Longer change alcohol like butanol, pentanol, solubility decreases as the hydrocarbon change length increases. And this is because the non-polar alkyl change is hydrophobic, water repelling, which describe H bonding with water. Solubility decreases with relative molecular mass because of the bigger hydrophobic area, and it is the mass of one molecule of a substance relative to 1/12 the mass of carbon, 12 atom, and it is measured in gram per mole. As relative molecular mass increases, the hydrophobic non-polar alkyl change gets larger, and this makes the molecule less polar overall. Therefore, hydrogen bonding with water becomes less significant and solubility decreases. This can be shown on the right-hand side of this presentation. Let's look into the hydroxy compound alcohol, specifically referred to phenol. Phenol is not completely soluble in water below 66 Celsius, but completely soluble above this temperature due to formation of a homogeneous mixture, critical solution temperature. Phenol is a colorless, crystalline solid which is hygroscopic. 4-nitrophenol is more soluble in water as compared to 2-nitrophenol due to less intramolecular hydrogen bonding and greater intermolecular hydrogen bonding with water. Acidity of phenol and alcohol. Phenol is a stronger acid than water, and water is a stronger acid than alcohol, like ethanol. Phenol can lose a proton H plus to form a phenolside ion, which is stabilized by resonance. Water can also lose a proton to form a hydroxide ion, but it is less acidic than phenol. Alcohol like ethanol are very weak acid, weaker than water. Ethanol as a very weak acid. Based on the above, but this equilibrium lies far to the left because ethanol does not easily donate a proton. And that is why it is considered a very weak acid. If refer to reactions with sodium, when ethanol reacts with sodium, so it produces sodium hydroxide and hydrogen gas based on this equation. Refer to the diagram on the right side. Phenol is the most acidic because the phenolside ion is stable. The negative charge on ion atom can be localized onto benzene ring to stabilize by resonance effect. That's all for today's session. I look forward to seeing you at the next session. Please subscribe to Jom Sadila YouTube channel and don't forget to turn on your notifications so you don't miss any update. Best luck in your studies and upcoming examination and wishing you every success. Thank you very much.